Okay, trig students, let's get started. Again, we're section 3.2. We just derived the law of cosines. Now we want to put it into practice. So it says solve the triangles given the following conditions. You know that A is 26, B is 12, and C is 15. So as we set this up, you're going to see how it looks different from the other ones before. Just going to draw a generic triangle with A, B, and C. Angle A is 26 degrees. Side B is 12 and side C is 15. Notice you have an angle in 26, but you have no opposite side. You have a side, angle, side. And in your notes, side, angle, side says right here that we would use the law of cosines, that we have one unique solution. It'll carry you through that. You have your list of formulas down below that you can check out. So I go back to my problem. In order to use the law of sines, I have to have an opposite side. So I want to solve for side A. This is side A over here. I need that opposite side. So I'm going to find it. And I use this formula. A squared equals B squared plus C squared minus 2BC cosine of A. Now, notice I use A squared as opposed to C squared up here. Up here I use C squared. Well, you choose whatever formula you want. It doesn't really matter what A, B, and C are. You just have to be able to decide which side you're solving for, then choose the appropriate one. There's lots of different ways to write this formula. So I just plug the pieces in. A squared is equal to B squared, so 12 squared is 144, plus 15 squared is 225, minus 2 times 12 times 15 times the cosine of 26. Now I know that looks really bad, but it's not. And what I like to do is I like to find out that. I like to find out that. And then take the square root of it in the end. So that helps just to avoid any problems you'll see in some of the other examples. As we try this out, first 144 plus my 225, I get the 369. So A squared is equal to 369 minus, now I do the other part. I'll do 2 times 12 times 15 times the cosine of 26. And I get 323.57. 323.57. Now, a word of caution. The cosine value of an angle can be negative if it's in the second quadrant. So if it's an obtuse angle, you can come up with a negative value. So this could sometimes be minus a positive number, and sometimes it could be minus a negative number. So you really got to be careful about whatever this portion comes out to equal right here. In this case, it was positive, and our rule says that we subtract it. So we'll carry on here. And we have 369 minus 323.57. I get 45.43. So A squared is equal to 45.43. If we square root it, we're going to find the answer. I'm going to set up my angles and everything over here so I can get ready. A, B, and C. Side A, side B, side C. Angle A, excuse me, is 26 degrees. Side A, we don't know yet, but side B is 12. Side C is 15, and we just find side A by taking the square root. Oh, looks like my calculator froze. What a time for this to happen. Actually, my smartboard froze. Oh boy. Okay, here it comes up. Okay, good. All right. No time to freeze smartboards when I'm recording. All right, square root of 45.43. 45.43. And we get 6.74. So 6.74. So we have all of our sides, but we only have one angle. Well, 6.74 up there, if I know that side is 6.74, I can now use the law of sines because I have an angle and its opposite side. So the sine of 26 over 6.74 is equal to the sine of b over 12. Now that we have this, we could solve for it accordingly. I'm going to encourage you guys that when you use the law of sines, you know, I could have done C, I could have done B. Go back and solve for that smaller one first when you use the law of sines. Trust me, it's going to help you out. Okay, trust me in that one. We'll talk more about when I get back from break. So we go through solving this. 12 sine of 26. We'll divide that by 6.74. And we will inverse sine that answer. 51.30. So B is 51.30. In order to find C, we just simply subtract the other two from 180. 180 minus 51.3 minus 26. 102.7. Now, here's my caution, you guys. I told you that when we went back to solve for the law of sines, that we used 12. Okay, so when I did sine of B, I could have chose C. I chose sine of B because 12 was smaller than 15. If you do that, you know that B is, because it's smaller, is going to be an acute angle, and that forces C to decide whether or not it's going to be an obtuse angle. So what I'm saying is that if we wouldn't have done that, we actually would have come up with a different solution for C that would be incorrect. So it's written in your notes accordingly. Just make sure that you go back and use the smaller side in that scenario. Use the smaller side in that scenario, and it should work out well. Notice our largest angle is our largest side. Also notice that our smallest angle has the smallest side. It looks like we have done this correctly. We're ready to move on to the next one. So I'm going to erase this, and we will make room for the next one. The next one says side A is 10.5, side B is 9.1, side C is 12.4. As I draw that triangle, notice I don't have any angles. It's another very useful way to use the law of cosines when you don't have any angles. So A is 10.5, B is 9.1, and C is 12.4. Once I find an angle, this will be easier. If you look at your decision tree, the decision tree tells you that you have to make sure that if you're given all three sides here on the end, right here, okay, that all three sides you have one solution. Use the law of cosines to solve a missing side. When you use the law of sines to find one of the missing angles at the end, start with the angle opposite the shorter of the two sides. Same thing with side angle side. I give that same note there. It will help you out. We go back. Again, we always need to know if there's an obtuse angle. And so my recommendation in this situation is to find the obtuse angle, because sometimes, you know, that could create the two situations for us, which is difficult. Just take my word for it. When you're given all three sides, solve for the angle opposite the largest side first. So when you're given all three sides, 12.4 is the largest. So we're going to solve for angle C. So that means that we need to use this formula. I'm going to write it down. C squared is equal to A squared plus B squared minus 2AB cosine of C. Why did I choose that one? Because I'm solving for angle C. It's the angle that has the largest side, so that if there is an obtuse angle, we're going to force it to show up, and we're able to work through it this way. My formula does have angle C in it, which is going to allow us to solve. So at that point, I just, I plug everything in. 12.4 squared equals 10.5 squared plus 9.1 squared minus 2 times 10.5, running out of room here, times 9.1 times the cosine of C. Notice our variables at the end there. We can solve this. There's not a problem. We just need our calculator and need to work through it. $12.4 squared, 153.76. Equals, let's do 10.5 squared plus 9.1 squared. 193.06 minus 2 times 10.5 times 9.1. 191.1 cosine of C. How are we going to solve this? Well, in order to solve this, we have to subtract 193.06 from both sides. We get 153.76 minus 193.06. We get negative 39.3. Negative 39.3 is equal to negative 191.1 cosine of C. How do we solve for this? Divide both sides by negative 191. Whoop. Negative 191.1 divided by negative 191.1. Negative 39.3 divided by negative 191.1, and we get 0.2057. 0.2057 is equal to cosine of C. We inverse cosine both sides. Second, inverse cosine of your answer. Come up with 78.13. So C is equal to 78.13. Now we can actually start listing off all of our pieces. A is equal to, B is equal to, C is equal to. C is 78.13. Side A, 10.5. Side B, 9.1. Side C, 12.4. How do we actually go back and find A and B, angles A and B? Now you can use the law of sines. Sine of 78.13 over 12.4 is equal to sine of A over 10.5. Now it's time to go ahead and solve for that, and you'll be able to figure it out. I'm out of time here. I got 10 seconds left, but that's how you could carry out that problem from there, and you should be able to use the law of cosines to solve this problem.